Okay, in this question, we're looking to find the equations of two tangent lines to the graph of f of x equals 2x squared that pass through the point 1, comma, negative 6. Okay, so we have a point on the graph here, and we have a point on the graph here, and we're looking for this tangent line. And then we have a point on the graph here, and we're looking for this tangent line. All right, so the equation of a line, we need, well, if we already have a point, we need the slope of the line. So if we know the point and the slope, then we know the equation of the line is y minus y1 equals m times x minus x1. That's the equation of a line, where m is the slope and x1 comma y1 is any point on the graph, any point on the line, So we have our x1 y1 is right here. That's the point 1 comma negative 6. Now we also know that the slope is the derivative of the function. So for a particular x value, let's say x equals c, if you plug in c to the derivative, that's the slope of the tangent line. That's sort of the crux of our whole study of derivatives. Okay, so let's see what we could do here. The slope of the line that goes through, so let's say the slope through the point 1, negative 6, and some other point, which we don't know, xy. So here's an xy here, so that's one point, x comma y. That's the point where the tangent line hits the graph of 2x squared. And here's the other point, xy. Okay, so the slope of the line through the one point we know and one point we don't know, well, that should equal y minus a minus 6, or y plus 6, divided by x minus 1. All right, so we have an x and a y here. Well, our function f of x is equal to 2x squared. Well, instead of f of x, we could call that y. Y is equal to f of x. So y is equal to 2x squared. So this 2x squared could go in for that y. So the slope of the line, instead of y plus 6, well, we could say 2x squared plus 6 divided by x minus 1. All right, because y is equal to 2x squared, so we could sub out a y for the 2x squared. Okay, so the slope of the tangent line. Well, we just saw it's equal to 2x squared plus 6 divided by x minus 1. And the slope of the tangent line is also the derivative of the function. So that should be x prime of x. So the derivative of 2x squared, so our function is 2x squared, our derivative is 4x. So now we have the equation 2x squared plus 6 over x minus 1, that's our slope formula, y minus y over x minus x, is equal to the derivative of the function, which is 4x. Okay, now we have one equation with one new variable, and we can solve this equation for x. So we get multiply both sides by x minus 1. So we can say 2x squared plus 6 is equal to 4x times x minus 1. And let's distribute the 4x. Okay, so we have 2x squared plus 6 is equal to 4x squared minus 4x. And let's bring everything to one side so we could use the zero factor theorem or factor and solve. So let's minus 2x squared from both sides. And let's subtract 6 from both sides. So we'll have 0 on the left. And on the right, it looks like we have 2x squared minus a 4x minus a 6. So let's see if we could factor this. And actually, everything is an even number here. Everything's divisible by 2, so we could divide both sides by 2. So let's say this is x squared minus 2x minus 3. And now, this we can factor. And then once we have it in factored form, the zero factor theorem says if two things multiplied together give you 0, then each one of those must individually be equal to 0. So x times x, 3 times 1, the 3 should be negative, the 1 should be positive. So we get two solutions here. X equal to 3 and x equal to minus 1. So these are the x values where the tangent line hits the graph of 2x squared. So it happens in two places. When x is 3, and that should say minus 1. X equals to minus 1. So at negative 1 and positive 3. So it looks like this point here is negative 1 comma something. And it looks like this point here is 3 comma something. Well, what's the something? Well, that's the y value. We need to plug negative 1 in for x to our function. So we need to figure out f of negative 1. And over here for the red one, we need to figure out f of 3. So those will be our y values. So in our original function, when x is negative 1, negative 1 squared is 1 times 2 is 2. So there's our point. Negative 1 comma 2. And when x is equal to 3, 3 squared is 9 times 2 is 18. So that point is 3 comma 18. All right, this problem is pretty much entirely algebra. The only calculus involved here, sort of right here, using the fact that the slope of the tangent line is equal to the derivative. Other than that, it's all algebra. All right, so we have two problems now. We have the point negative 1 comma 2 and the slope, which is equal to the derivative, which we said is 4x, which if we plug in our x value, negative 1, we have a slope of negative 4. And then for the second problem, we have the point 3 comma 18, or for the second line, we have the point 3 comma 18, and the slope of that tangent line is the derivative. And if we plug 3 into our derivative, we get 12. So now we have a point and we have a slope. So applying the equation of a line, y minus the y value is equal to m times x minus the x value. And if we multiply through the minus 4, we have y minus 2 equals negative 4x minus 4, or y is equal to negative 4x minus 2. So there is our first tangent line. And then for the second one, we have a point, we have a slope. So y minus the y value is equal to m x minus the x value, or y minus 18 equals, we'll distribute the 12, so that's 12x minus 36, or y is equal to 12x. If we add 18 to both sides, that will give us a minus 18. All right, so that about does it for this problem. Again, a lot of algebra here, using the idea of a slope, the idea of the derivative being the slope of the tangent line, and our ability to find the equation of a line if we know one point, which was given, and one slope, which comes from the derivative of the function.